Okay, so we are talking about radians and degrees today. Everything we can shove into 50 minutes, right? Okay. We're going to be using the angles on a coordinate plane, and the very start of the angle is always called the initial side. It starts at the x-axis, the positive x-axis, always starts on the positive x-axis. The center or the point or the vertex of the angle is at 0, 0. Then the angle rotates counterclockwise to an ending side, an ending ray, and that's called the terminal side. So we've got initial side, terminal side. We have an angle in the middle, or a little arc in the middle showing which way you rotate. If the angle is given to you positive, like positive 50-degree angle, it rotates the way I just showed it to you. If it is a negative angle, then you would still start at your initial side and you would rotate clockwise somewhere. So this would be about negative, just guesstimate an easy angle, that would be about here. Negative what? I was thinking negative 100. The 250s throw me off a little bit. We're starting at initial side, we're just going to here. That would be maybe a positive 250, but if we're thinking negative, going this way, then it was only like 100 degrees. Okay? The entire circle, if we go all the way around, you should already know, has 360 degrees. The degrees is its unit of measure. And then there's a different unit of measure that we're going to use even more than degrees, radians. 2 pi radians would be all the way around. That is also a unit of angle measure. You guys know us crazy people in the United States, we measure things in like lengths in what? Inches? It's like so hard. I don't know how to do that. Because everybody else in the world measures things in what? Centimeters. So they still measure the same thing. Like 12 inches is approximately 30.6-ish. Centimeters, like you're still measuring the same thing, just different units of measure. This is what degrees and radians are. They're measuring the exact same thing. They're just different units. 360 degrees in the entire circle, or 2 pi radians. They're still measuring the same thing. So what is a radian? You know? Anybody know what a radian is? Do you know? Logan? Yeah. I have a little video. I show this every year. It's a visual representation of what is a radian. And it's really slow, so I'm going to try to speed some of it up. But what Logan said is you take the radius, and then you start anywhere on the circle, and you measure around the circle lengthwise the radius, whatever that measurement is. You take it and you measure it around, that's the radius. So now this angle is called 1 radian because its arc length, this little section of the circle, is 1 radius. So then what this picture is showing you now is we're taking this radius and we're just going to measure it a second time. It's just really slow. Oh, I can change the speed, can't I? Oh, I forgot about that. Yes. A little bit faster. So anyway, so now what we're doing is we're starting at the positive x-axis. We're measuring 2 2 radii, and then we add together these 2 angles, and that makes 2 radians. Huh? Where do you think 3 radians is going to be? Any guesses? It goes real slow. You got lots of time to guess.
180.
Think it's going to be 180? No? Not yet? 3 radii stop short of 180 degrees. You don't like that.
How many degrees is 1?
Give me a moment to answer that question. Okay, so 3 makes it almost to 180 degrees. You know why?
There's not enough to cover the whole thing exactly.
How many radians?
6.2.
Oh, I want to know exact. How many radians in the whole circle?
6.28.
6.28 is not exact. That's around
2 pi.
2 pi. 2 pi is the exact. Right? 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 Right?
Yeah.
Okay. So 6.28 is an approximation, but 2 pi is the entire radians in the whole circle. So if I go halfway, how far is it? Pi. What decimal approximation is pi? 3.14. So when I say 3 radians, that's why it's not all the way, because all the way is 3.14 radians. So when we say 3 radians, that's like 3.0 radians. So then somebody already read how many radians approximately are in the whole circle. Approximately. 6.28. Double 3.14. Double 2 pi. Double pi. So anyway, this continues and shows you like all the way around. Just takes forever. So there's 6 radians. It's not exact. Did they show the whole thing? No, that's it. Okay. So here is a picture of what you just watched. It's not perfect. It's not exact, but it's approximately 6 and then 0.28 in the entire circle. And what's going to happen is if they ever give you radians in decimal form, like where is 4.5 radians? You heard it a lot last year with pi. You're going to see some of them without pi. So if I say, where's 4.5 radians, you're going to have to say, well, that's like right in between 4 and 5. It's somewhere about there-ish. Okay, so this is there for you just like use as a visual representation of the decimal form. Now, let's talk about exact form. There were certain radians that you have to know in here. There's certain ones you have to know. Some you don't have to, but certain ones you have to know. So the main ones you have to know. You have to know that this is 0, or if I go all the way around, radians, 2 pi. I know you guys already know the angles, so we're not going to really talk about the angles. We are going to use angles today, but I'm not going to spend the most of the lesson on the angles. I'm going to spend more of it on radians. So all the way around 2 pi. So that means halfway around is what? Pi. Now, I think it is easy if we figure out the rest of all of these angles by using the top half pi. Pi is really easy to do multiplication and division with. So if I'm looking at just the top half right here is divided into how many equal angles? So if I take pi and I divide it by 2, this is called pi divided by 2, pi over 2. See how I did that? I took the top half
and divided it by 2. Now, once I do that, that tells me that each of these sections measures an angle, which we're going to call theta. Each of those measures an angle of pi over 2. So this would be 1 pi over 2. The second one would be the same thing as 2 pi over 2, which reduces to pi, and we should already know that one's pi. If I go around one more, I'm now at 3 pi over 2. If I continue to go, I am now at 4 pi over 2, but that reduces to 2 pi. I could keep going if I want. This is also 5 pi over 2, 6 pi over 2, 7 pi over 2. Like, it goes on forever.
Yeah.
Do I just go ahead and head over?
Yeah.
And then you're going to want to watch these notes. Well, maybe you know this stuff already. All right, so those are the pi over 2s. Those are really important. We need to know those. Real fast before I move on to the next one, what if I started, here was my initial, and this was my terminal, and then the arc showing you which way I went looked like that? What would it be? Negative pi over 2. You're going down now. All right, so those were the pi over 2s. I took the top half and divided it by 2. Oh, and what degrees are each of these? Visually, you should say 90. If you know that pi is 180 degrees, then pi divided by 2 has got to be 90 degrees. Okay, next one we're going to do is start with your 0, 2 pi over here, start with my pi over here. I'm going to look at the top half again, but I'm going to take the top half and divide it into 4 equal thetas. So I'm taking pi and dividing it by 4. So the first one is pi divided by 4. Now, if I want to know the degrees really fast, then I just think, what is 180 divided by 4? I wrote 45. Yeah, 45. Okay, so this is pi over 4. The second one is 2 pi over 4, but we should already know that because it reduces. That one's pi over 2. The third one is 3 pi over 4. The fourth one is 4 pi over 4. The fifth one is 5 pi over 4. The sixth one is 6 pi over 4, but it does reduce to 3 pi over 2. The seventh one is 7 pi over 4. The eighth one is 8 pi over 4. The ninth one is 9 pi over 4. Like, we can just continue to go. Pi over 4 is 45 degrees. Pi over 4 is 45 degrees. This is like me trying to help you start memorizing. Pi over 4 is 45 degrees. Pi over 4 is 45. Got it? Hear my annoying noises I made. All right. What are your colors that you... Pick 2 colors that you definitely think. Pick 2. Any two. Blue, right? Now my third one, I am starting here at 0, 2 pi. Going over here, halfway through is pi. I'm going to take the top and divide it into 3 equal sections. If I'm thinking degrees-wise, 180 divided by 3. So I'm just approximating this here, 60 degrees each. But there's only 3 sections, so this one does not land on 90 degrees. 60, 60, and 60. So I just took pi and I divided it by 3. So pi over 3 is our first one. Our second one would be 2 pi over 3. And then 3 pi over 3 is just pi. And then we keep going to 4 pi over 3. 5 pi over 3. And 6 pi over 3, which is pi. I can also use this exact same picture, bless you, and divide it into 6s. So if I could divide pi into 3s and then just half of those, then I've got 6s. So what did I just divide pi by? 6. Pi divided by 6 is 30 degrees. Pi divided by 3 is 60 degrees. You see how those are like opposite? People confuse those. They want to say pi over 6 is 60, but that's not true. Pi over 6 says 6 goes into 180. 30 degrees. Okay. So pi over 6 is here. My second pi over 6 is at pi over 3. My third pi over 6 is at pi over 2. You should already have that number. Fourth pi over 6 is at 2 pi over 3. My fifth pi over 6 doesn't reduce, so it gets its own spot. 6 pi over 6 reduces. 7 pi over 6 does not. 8 pi over 6 reduces. 9 pi over 6 reduces to 3 pi over 2. 10, oops, 8. I lost something. What was it? Where'd it go? Oh, it's up here. Why did it go over there? You see what happened? Come back. There. Where was I? So this would be, oh shoot, 7, this was 8, this is 9, this is 10 pi over 6, and then we've got 11 pi over 6, and then 12 pi over 6 all the way around. So the pi over 6s that were missing were the ones that did not reduce anyway. So you should be able to go back and forth between degrees and radians if it's divided by 2, divided by 4, divided by 6, and divided by 3. You should not need a formula for those. You should not need a formula for divided by 2, divided by 4, divided by 6, divided by 3. There is a formula for all others, which we'll get to like the last part of class. Okay, this says sketch an angle in standard position, find the measure of the angle in degrees and radians. We're going to start with our initial side. And this says to do 1/3 rotation around the entire thing counterclockwise. So counterclockwise says we're going positive. 1/3 of the entire 360 is 120 degrees. And that would be about here. And you have to draw this rotation arc to show me which way you're rotating. So I have the angle in degrees. Can we figure that out without taking out our calculator and any conversion things? Can we figure that out in radians? Let's just think about this being pi. And this is 120 right here. There's got to be some pieces that lead up to 120. What do you think, Ben? Oh, you were telling me the answer already. What were you telling me? Change your mind. What is an angle? 45, 30, 60. What's an angle that goes into 120 evenly? Out of these angles. 60? Okay, how many 60s fit in there? So the first one is pi divided by how many 60s fit in the whole thing? How many 60s fit in 180? So this is pi over 3. So this is what? 2 pi over 3. Brilliant. Okay. 7/4 rotation. So we start with our initial side. It's going C. What C stand for? Clockwise. So 7/4 rotation says the entire 360 degrees divide it into 4 and do 7 of them. It says divide it by 4 and do 7 of them. So the whole thing, if I divide this by 4, what is each one? What is each one? 90. And how many am I going through? 1, 2, 3, 4, 5, 6, 7. So 90 times 7 is 630, except which direction did I go? Went clockwise, so you have to write negative. Negative just says which direction you traveled. All right, we're going to take that and we're going to convert it to radians without using a conversion formula. We're going to use our brains and like second, third grade fraction work. All right, this is pi. What's actually it's negative pi if we go this way. What's this one here? Negative pi over 2. So we're counting by pi over 2s. You have to do 7 of them. 1, 2, 3, 4, 5, 6, negative 7 pi over 2. Counted negative 7 of them. Great. The next section talks about coterminal angles. Co would mean kind of like together. Terminal means they have the exact same terminal side. Can somebody give me an angle that is not negative 630 degrees? Not that one. Any angle that has the exact same terminal side. Of course, it's the same initial side because it's always the same initial side. Somebody give me an angle that has the same terminal side. Positive 90 degrees. Excellent. Can somebody give me a negative version of the same terminal side? Negative 270. Are those the only options out there? So if I were here at 90 degrees and I wanted a different positive angle, what could I do? How far around? So you can keep adding or subtracting 360 to get any coterminal angles at all. So the next section says, let's find one negative and one positive coterminal angle for each of the given angles. We're not going to do all of these, okay? So the first one, 30 degrees, I need to know one positive and one negative that's coterminal. So you either add 360 or subtract 360. What's the positive coterminal? 390. And negative coterminal? Negative 330. What does it mean to anybody who is not in our class that looks at your paper, who knows math, if you don't put a degree symbol? You know what that means? Did I say it yet today? You don't put a degree symbol, it means radius. So if you don't put a degree symbol, I'm going to assume you meant radians. You're probably going to get it wrong. 390 radians is way different than 390 degrees. Make sure you don't be lazy. Like, put the degree symbol in. Okay, let's look at E. Pi over 3. I need coterminal. But anytime you see a question that's in radian form, you put your answer in radian form. So we're going to think radian form. So I'm not going to add or subtract 260. What am I going to add or subtract? 2 pi. Excellent. So I'm going to take pi over 3 and add 2 pi. Oh no. Problem. How do you add anything in math? Well, that's specifically for fractions. Adding anything in math. How? You just can't like. How do you add, can you add 3x and 5x? You have to have like terms. To add anything in math, you have to have like terms. So we think fractions, so we say, oh, that's common denominators. So what's my common denominator? So pi over 3 plus 6 pi over 3 is 7 pi over 3. We also have to find the negative, so I'll do pi over 3, take away 6 pi over 3, negative 5 pi over 3. Radians. Okay, next section. This is where you're going to need your calculator. Degrees, minutes, and seconds. I heard Andres did this last year. I don't think CP, my CP classes did not do it, so I doubt anybody did, because it wasn't in our book. Anyway, if you see an angle written with an apostrophe and then a double apostrophe, this is, this angle here is the same as 25.2625 degrees. It's just kind of written in a different format. So instead of decimal format, it's something called minutes and seconds related to an hour, but this is not hours. But there's 60 minutes in an hour, so you do 15 out of 60 as a fraction of that degree. And then there's 45 seconds. No, there's 3,600 seconds in an hour, and then there's 45 out of those 3,600. So that's another fraction that we would add on each decimal version of those fractions, and that's how you get that. Easy? Or you can also use your calculator. So what I want you to do on your calculator is go ahead and type in 25, and then I'll show you where to find everything if you don't know. So this would be the thing where you might want to write it down if you don't have your calculator today. I need help if I turn my light on. Okay, so 25, and then there's a button. It is second, and then it's the apps button, but has the word angle on it. That makes sense. Angle. Okay, so second angle, and you will see the degree symbol. So we're gonna hit enter, and then is it 15 next? Is that the next number? Yeah. And then we have to do minutes, and that is also under second angle. You'll see number 2 is minutes. And then 45 seconds. That is not under the angle button. I don't know why. It's actually alpha plus sign. It's on the plus sign way down here. Alpha plus sign. There's your little quotation. Don't know why it's not under angle, but that's where it is. You're going to hit enter. And boom, it's done it. Oops, I didn't hit enter. There you go. Done it for you. So if you need to convert, you can use your calculator. If you don't have your calculator, I guess you're going to have to do it by hand. We can also convert from decimal form into degrees, minutes, and seconds. And I gave you a 99 point something. I forget. Where is it? 0.252. Thank you. So we can convert that into the degrees, minutes, and seconds. To do that, excuse me, it is also under the angle button, so second apps or angle, and you'll see choice number 4 says DMS, degrees, minutes, seconds. So choice 4, enter, done. 99 degrees, 1 minute, 30 seconds. Okay, you're going to use that a few times. So make sure you have that written down, or you keep practicing it, or you go back and watch this video if you forget. You can probably find it on the internet too. Is it 1? 1 and then 30. All right, in which quadrant is the given angle found? So they're going to call them theta. And the quadrants go in counterclockwise. And they are Roman numerals. That's how they're labeled. So for this one, 110, we go to our initial side, draw the first side of the angle, terminal side at 110, draw an arc showing which way you rotated, and then which quadrant is that in. Second, so 2. Pretty easy. How about D? So D, I'm not about to pull out a calculator yet. I'm going to use what I was going over earlier. Fractions from like 2nd and 3rd grade. What's the top half in radians? What's the top half in radians? What's the whole thing in radians? What's the top half in radians? Okay, pi. This says take pi and divide it into how many equal places? Okay. There's 2. There's 4. There's 8. How many of those am I traveling through? Did I need a calculator for that? There it is. 7/8 pi. Quadrant 2. Let's do F. Initial side. Terminal side is negative 5 radians. Was there a pi in that radian at all? Then it's in decimal form. So that's where you go back to the front page that has the 6.28 radians, and you approximate where 5 would be. I know all the way around, and this was going negative, all the way around is 6.28. So 5 is going to be, I don't know, about here-ish. Quadrant 1. Remember, negative goes down. So if there's not a pi, then you have to use that decimal picture. We're doing okay. I know it's a lot. All easy stuff. Almost done. The next section it talks about complementary and supplementary. You should know that from geometry. If they're complementary, they add up to be 90 degrees. If they're supplementary, 180 degrees, except we're not doing it in degrees. So we've got pi over 2 is 90 and pi is 180. So if you know one of the angles is, also they have to be positive. One of the angles is 2 pi over 5. We're going to find the other. So for complementary, take your sum, pi over 2, subtract off part of it, 2 pi over 5, to find the other part of it. Common denominators, 5 pi over 10 minus 4 pi over 10. 6 pi over 10. Complement. Supplement, you're going to start with your total, should be pi. Subtract off your part, 2 pi over 5. So that's 5 pi over 5 minus 2 pi over 5. take your sum, subtract off the part that you know, get the part left over. So to do the complement for part B, you have to start with pi over 2. You have to subtract off 4 pi over 5. So that's going to be 5 pi over 10 minus 8 pi over 10. Gives me negative 3 pi over 10. Which breaks one of the rules that I underlined about complementary and supplementary. What rule did I just break? Has to be positive. This is not positive. It means there is no complement. I ran no complement. That's because 4 pi over 5 is bigger than 90 degrees already. So then supplementary, if I have pi, which is 5 pi over 5, minus 4 pi over 5, I get pi over 5 as my supplement. That one works fine. It's just the complement didn't work well. Okay, then the very last section is converting between the two. We're going to do so many conversions in this chapter. This is an easy conversion. Make sure we understand it. So we're going to do so many. Anybody in physics right now? 3 people? No way. 4 people? Huh? They're slowly coming up. Okay. So we're going to do physics in here as well. We complement the physics course. Anyway, there's a lot of conversions. Did you guys have to do that conversion thing like first day? Did you do that big conversion thing? You know what I'm talking about? All right. So, anytime we convert, you have to multiply by a value of 1. You can't multiply by any other number or it changes the value of that number. If you multiply by 1, it keeps the value the same. So pi radians in 180 degrees has a value of 1 because what do you know about pi radians and 180 degrees? They're the same. So this has a value of 1. So to convert between degrees and radians, we multiply by a value of 1. So to convert this degrees into radians, we're going to multiply by pi radians over 180 degrees. I put 135 over 1. Some of you still don't know how to multiply by fractions. I found out when I was grading your tests. We multiply fractions just straight across. You can only cancel stuff if it's on the top and the bottom, so I'm going to cancel my units of degrees over degrees. I'm going to be left with 135 pi radians over 180. And then, does 135 over 180 reduce? It does, eventually, to 3/4. 3 pi over 4. So you multiply by a value of 1, and it has to be a value of 1 that cancels degrees from top. Leaves you with radians on top. So for all of these, I'm not going to do them all because this is just simple multiplication and reducing. For all of these, you have to make sure that you're canceling the degrees by dividing by degrees. Radians goes on top to change. Okay? The next section is convert the radians to degrees. To convert radians to degrees, you have to multiply by a value of 1, but you can see this value of 1 switch now. 180 degrees over pi radian. We do that so that our radian units will cancel, and we are only left with degree units. So multiply that together, and I can reduce the pi's and the 2. So I get negative 90 degrees. Look at the very last one, 2 radians. We want it to be in degrees when we're done, so we multiply by degrees. But you can't just multiply by 180, you have to multiply by a value of 1, and it's going to cancel the radians. So we cancel our radians. You get 360 divided by pi degrees. That's the exact answer. If that is bothering you, then you're going to have to use your calculator. It's approximately 114.59 degrees. Okay, so I'm going to put the assignment up. It is in the book. And I was kind of saying this as people were walking in. If you'd like to check out a book because you know you are a book person, I have books available to check out. I've also taken screenshots and uploaded it onto Canvas, or you can just take a screenshot on your own phone before you leave here of these pages. I'm going to get out of the way before you take a picture of this with me. Let me just stop the notes though.